Hello, lovelies. In today's video, we are going to learn how to count atoms in a chemical formula. So before you begin, you might want a notes template, and if you do, go ahead and grab this from the DIY bucket. This is what the notes template looks like. Pause the video while you go get it. Before we dig in, it's important to know what you're going to be learning about. So in this video, you have a couple need-to-knows that you're actually going to be able to answer. The first of which is, what is the purpose of a subscript in a chemical formula? What does the coefficient tell you about the chemical formula? How can we determine the number of atoms of each element? And how can we determine the total number of atoms in a chemical formula? So you might be thinking that this sounds really intimidating, but it's not. I promise you it is actually pretty easy. Let's begin. First, remember a chemical formula represents the kinds of elements and the number of atoms a substance is made of. Here we have two substances represented by chemical formulas. We have water on the left and hydrogen peroxide on the right. Now remember, chemical formulas represent substances, and substances have common names and chemical names. Water would be a common name, but hydrogen peroxide is a chemical name. And these chemical formulas show us that what elements and how many atoms of each of those elements each of these substances are made of. For example, water is made of 2 hydrogen atoms and 1 oxygen atom, and hydrogen peroxide is made of 2 hydrogen and 2 oxygen atoms. And when you have different combinations of atoms, different kinds of elements, and different numbers of those elements put together, you get different substances with different properties. And we use the chemical formula to break down how many atoms of each of those elements we have. Subscripts and coefficients are part of a chemical formula, and they show us how many of each element is in each substance. The coefficients and the subscripts are identified in this picture. The coefficients are the big numbers, the subscripts are the little numbers. Subscripts are small numbers behind the element. Subscripts show the number of atoms of the element. If the subscript is blank, like on oxygen here, it doesn't have a number, it means it's 1. The coefficient is the big number at the front of the formula. Coefficients tell you the number of molecules that there are of the whole substance. It's a multiplier, essentially. Again, if there's no number there, it's just 1. So how do you use subscripts and coefficients to count atoms in a chemical formula? So here's 4 steps. First, you need to list all of the elements. Then you identify the subscripts of each of those elements. And remember, if no subscript is listed, it's 1. Then you multiply the subscript of each element by the coefficient to find the total atoms of each element. And then you add up all the atoms to find the total atoms in the substance. Don't worry about writing all of that down. What you need to know is how to use that and how to practice that. So we're going to practice 6 different times. So let's begin with a super easy one, water. First of all, we list our elements. Well, we have hydrogen and oxygen in our formula here. Those are the elements. So we have 2 elements total. Now we're going to look at the number of atoms of each of these elements. And that, remember, we look at the subscript first. So hydrogen has 2 here. Oxygen has 1, and then we multiply the subscript by the coefficient. So little number by big number for each one. So 2 hydrogen atoms times 2 for the coefficient gives us 4 hydrogen atoms, and 1 atom of oxygen multiplied by the coefficient of 2 gives us 2 oxygen atoms. So those are the number of atoms of each of our elements, which gives our total number of atoms in the entire substance is 6. Let's practice one more time. Here's glucose. Glucose is C6H12O6. Our elements are carbon, hydrogen, and oxygen. And the number of atoms of each element, in this one it's really easy because we only have our subscripts here, and it's super easy. So we have 6 carbon, 12 hydrogen, and 6 oxygen, which makes our total number of atoms 24. Hydrogen peroxide is H2O2, and in this one we have 3 molecules of hydrogen peroxide of H2O2. So our elements are hydrogen and oxygen. Our number of atoms of each element, we take our subscript for each, we multiply it by our coefficient. So 2 times 3 gives us 6 hydrogen, 2 times 3 gives us 6 oxygen, which means our total number of atoms in the entire formula is 12. Are you getting the hang of it? I really hope you are. If not, stop and ask your teacher. Now, sometimes you'll see parentheses, and I don't want you to freak out because really it's just like math class. You multiply the number outside of the parentheses by everything inside of the parentheses. So this 3 gets multiplied by the subscripts of each element inside. So first we list our elements. We have aluminum, oxygen, and hydrogen. Now we look at the atoms of each element. You got to be just mindful when you have a coefficient because you do have to still multiply it by everything. So aluminum, subscript of 1 times 2 gives us 2 aluminum atoms. We have our 3 on the outside of the parentheses here. So 3 times 1 for oxygen times 2 for our coefficient gives us 6 oxygen atoms. And then 3 times 1 for hydrogen times 2 gives us 6 for hydrogen. So you might want to pause and kind of write that out so you can actually practice this. And you will practice this more, but it might help you to write it down. So once we have our atoms of each element figured out, we can add them all up, and that gives us 14 total. Let's practice another one with parentheses. So first we list our elements. We have sodium, phosphorus, and oxygen. We look at our subscript. So we don't have coefficient, which makes it easy. So sodium is 1. Then we take this subscript outside of the parentheses, multiply it by everything inside. So 2 times 1 phosphorus gives us 2 phosphorus atoms. 2 times 4 oxygen atoms gives us 8 oxygen atoms. So there's our breakdown of each element. And then our total number of atoms is 11. Last one. Sometimes you'll see elements repeated in a formula. That does not mean it's a different element. All it means is that it's just bonded differently, and you still count it as that same element. So we only have 3 elements in here. Yes, we have 4 letters, but we only have 3 elements: carbon, hydrogen, and oxygen. We just see hydrogen twice, but we don't count it twice. That gives us 1 carbon atom. We actually have 4 hydrogen atoms because we have 3 here and 1 here. We add those together, and we have 1 oxygen atom, which means 6 total atoms. That's it. So you'll practice this more, and the more you practice it, the more you'll get the hang of it. And remember to ask questions if you need help.